sigma means, guys? Yeah, but it's population standard deviation. So if we're trying to estimate like the hilarity and the quality of cow drawings, if I asked this whole school to do it, and I only took a sample of 6 of you, you see how there's no way I could know the population standard deviation? All I have is S. And then it has to be normal, or N has to be greater than or equal to 30, one or the other. I wrote on this sheet that we're assuming that it would be normal distribution. These are in the problem. I'm going to go down to number 1. All right, you randomly select 16 coffee shops, measure the coffee temperature sold at each. The sample mean temperature is 162, standard deviation of 10. This, by the way, is the kind of math that they used to prove there was this case where a lady sued McDonald's because she got a cup of coffee and then accidentally spilled it in her lap while she was driving and got like intense burns, like horrible, like disfiguring, like go to the hospital burns because they accidentally had their coffee like super high. And then they went around and checked a few different McDonald's to see what was happening. I think she won like millions of dollars for it too. And pretty awful. And then they had a Seinfeld episode where Kramer kept trying to spill coffee on himself, but the coffee wasn't hot enough, so he'd scald himself, but not like enough for like a lawsuit, and he just kept hurting himself over and over again. It's pretty funny. Okay, so sample standard deviation. You see how it doesn't say population standard deviation, so that means that we've got X bar is 162 and S is 10. That's sample standard deviation. And it says that it's normal, so check. Number 2, you need to find M, X bar, and S. These are also in the problem. Or you might have to do like the list, edit, one variable stats, like you had to do today. Is your calculator working now, Caleb? Okay. So this is kind of number 2 over here, except for I'm also going to add that N was 16. They went to 16 coffee shops. Is this too light? Want me to get a darker pen, or can you still see it? Everybody okay? Okay. If you're struggling reading something I'm writing, let me know. Number 3. Now you're going to find the degrees of freedom. And your critical values, which this time is going to be called T sub C instead of Z sub C. So instead of having a Z score, we're going to have a T score, and we're going to be using a different chart. So take out that chart I gave you. A degree of freedom is N minus 1. Do you remember when we had like a sample standard deviation, we would divide by N minus 1 instead of N? Anybody remember that happening? So you divide by N minus 1 instead of N. Does anybody remember why you did that? No. That is like area under a curve. I'm talking about like sample standard deviation back when we did like standard deviation by hand, and then at the end we would divide by 1 less than how many we had. And the reason for that is because if you have a sample, we're assuming that the outliers aren't in there, the weirdos that are extreme. And so we're kind of making the thing a little bit wider. And that's the same reason for this, is why we're doing N minus 1. Now the nice thing about a T-chart is it actually just tells you exactly what you need to know. So everybody look at the T distribution that I gave you. The degree of freedom is N minus 1. So what is the degree of freedom for this problem? What'd you say? 15, because N is 16. And then we need to find out T sub C. So you see how it says that it is a 95% confidence interval? So you are going to be looking at the top of this sheet where it says level of confidence. On this sheet, they have 80%, 90%, 95, 98, and 99. There will not be anything other than these 5 on the AP test and on anything in your book, because this is the chart they gave us, and that's the only way we can figure it out. This is done by calculus, but they just didn't bother to do all the other levels of confidences because it would take too long and take up too much space. So you scroll down to the degree of freedom you want, in this case 15, and we're at a 95% confidence, so our number is 2.131. Which is also how many standard deviations you are away from the mean, just like a z-score, 2.131. T sub c is 2.131. Okay, then the next step is to find the margin of error. Find the margin of error, okay. And error is t sub c times s divided by the square root of n. This should look familiar to you. Yesterday we were doing z sub c times sigma divided by the square root of n. Almost exactly the same thing, but instead of a z-score, it's a t-score, and instead of sigma, it's s. So let's find the error. Error is going to be 2.131 times s, which was 10, divided by the square root of 16. So in your calculator right now, take 2.131 times 10 divided by 4. I got 5.33. Did you guys get the same thing? Okay. All right. Next thing is you're going to make the confidence interval. Is this too childish, or do you like having steps? When you make your confidence interval, it looks like a TIE fighter. And then you just add, oops, I didn't mean to write 162 in there. That is a very specific number for this problem. Please don't write 162 in the middle of every confidence interval you ever make. What time do you wake up in the morning? So the average is 162. X bar goes in the middle. This one's going to be X bar plus the error, and this one's X bar minus the error. But if we go down to my work, and that's where 162 will be in the middle in this problem. And then we're going to add 5.33 and subtract 5.33. So I get 156.67 and 167.33. Take a wild guess what the last step is going to be. Write a sentence. Put it in context. Put it in context, one sentence. So let's see, my sentence would be, I am 95% confident. Remember, it's not like if I went and looked at all coffee shops that 95% of them would fall in this window. I am 95% confident that the mean temperature of coffee in all, and that's important, all shops is between